Okay, all you 2JZ fans out there, this is probably part 2 or 3 of the 2JZ run stand build. And I've got quite a bit done on it. You know, I got the intercooler mounted and the turbos mounted. I got the oil lines, the oil drain lines. Everything's coming together. But I got to a point where I wanted to kind of like design, whatever you want to call it, a cam trigger. Okay, so this is a GE, so they don't come with a cam trigger, okay, a cam sync. Depending on what year you have, so if you get a GE that's kind of a newer GE, it might have a crank trigger already. Some do, some don't, okay? This one actually does. So it must be a newer year GE, and it already has the crank trigger. It's got the hole in the oil pump and all that. If you get a GE that doesn't have that, you can always get the GE pump that has the crank trigger in it, or you can use a GTE pump. It'll give you more oil pressure. There's some people who don't like that, some people who do, and there's a debate on that. But the point is that you just want to get an oil pump that has the trigger assembly, or the hole for the trigger. And then you'll have to get yourself a gear, okay, some kind of a crank gear that's going to be able to trigger for you. This is a 12 tooth. That will work, or you can get the more modern 32 -2 or whatever that is. But anyway, you're going to get one of those gears. So you have your crank trigger, but you need a cam sync. So I'm coming up with, I've been kind of throwing around some ideas here. This is the pulley, you know, for the serpentine belt pulley. And I pulled it off to try to make, I got these little aluminum standoffs here. And I'm trying to design a little bracket, okay, for this trigger right here. So I got, these are from DigiKey. These are Hall sensors, and I put a little boot on it. But this is what I'm gonna use, okay, to trigger. So this is gonna go right in this area here. And I have an idea of how I'm going to, you know, what's gonna trigger that. I know you can get these kits. Tons of people sell these kits. I totally get that. But, you know, me being the DIYer that I am, I like to try to do stuff myself. I got this super cheap. Actually, I got it for free. I just contacted the company and they sent me a sample. So I'm gonna try it. I'm not 100% sure if this will work. I'm pretty sure it will. It's got all the same specs as a regular Hall sensor. So we're gonna try it, okay? So this is what I've come up with so far. I got some longer screws and some aluminum standoffs. I'm still coming up with the right height. I'm not 100% sure what the height needs to be, but so this is gonna be like kind of a mock-up, okay? This metal, this is just really thin aluminum. You know, eventually, if I get this to work, I'll like order some good aluminum, some thicker aluminum, and then, you know, make a CNC program, and we'll do it on my little CNC here. And that way it'll be, you know, repeatable, it'll be the same every time. But I like to do like just a hand, you know, this I just kind of shaped by hand, and just to get it to where I know what I need, okay? So let me go ahead and put some holes in this, and then I'm gonna try to mount it, and let's see where this ends up. All right, so that fits pretty good. Kind of tapers around the outside of the pulley there. And I went ahead and threaded this with the same thread as this, which is 12 millimeter by 1 pitch. So let's see if this threads in here. See how we did. It's gonna be tricky doing this with one hand. So this has 2 bolts. You could, in theory, I guess you could put one on the other side and tighten them both down, but we'll just tighten one for now. Okay, so there you go. It's pretty close, but it does clear with, I mean, it clears quite a bit, the actual pulley. But as you can see, this, you know, this is a little too flexible here. I mean, it would probably work, but I need at least like, I don't know, a 1/4 inch material, or yeah, at least a 1/4 and 1/8. This is like, I don't know, I'm not sure what it is, but it's like a real thin sheet metal that I was using to actually make a panel for something, but it was just what I had laying around. So, but that should work. Okay, now we have to figure out a way to trigger this. Okay, so obviously it's not going to trigger on anything here. It needs a 1.5 millimeter gap on a piece of metal that when it swings by, it's going to trigger that. Okay, so my idea was to TIG weld something onto the washer. I don't know if this is going to work. Maybe you guys can give me some feedback on this. It's just kind of an idea I had, that what would be nice if it was on the washer itself. Okay, if there was something that was sticking out on the washer itself, that you could, in theory, you could move it around and adjust it to wherever you wanted to. So one of the issues, I mean, a lot of ECUs can correct this, but what you don't want is, you don't want your trigger, your cam trigger and your crank trigger to line up, okay? Because then the ECU will get confused. Now, you know, you can change it in the ECU to like rising edge, falling edge, or whatever, to kind of give you that gap of, you know, where, so they don't line up, the signals, okay? So, but I mean, it would also be nice to be able to adjust this where you want it, and then tighten this bolt and it wouldn't move, okay? I thought that would be kind of a good idea. I don't know if that's gonna work or not. So the first thing I do wanna try is to see if I can get this to trigger. So I'm gonna hook this up to a power source, and I'm gonna run a piece of metal by it and see if I can get it to trigger. And if I can, then I know that, you know, this will work for what we're doing. So, yeah, let me set that up, and let me see if I can get this thing to trigger, and then we'll go from there. And maybe I'll pull this off and see if I can TIG weld something on it. And then I can actually, what I can do is turn the motor over. I've got the starter and everything on it, okay? And we can hook the battery up to it, and I can actually turn it over, and we can watch an oscilloscope, or in my case, it would be just a multimeter, and we can see if we can see a change, okay? And if we can, that means it's working, okay? So let me do that. Let me see what I can come up with that, and we'll go from there. All right, so here's what I come up with. And it's hard to focus for some reason because it's so small. Maybe I'll put it here. But I tried to keep it like with a sharp edge. This is just kind of freehand. I know it's not perfect, but this is just to kind of prove the concept. Maybe it'll work on here. Oh, that's better. But yeah, I just wanted to make it so it's kind of square edged so that it would trigger. So this is gonna get welded onto here, and it'll sweep the Hall sensor. Yeah, so I'm gonna pull this nut off. Hopefully this doesn't come off or anything like that, and I'll take it over to the TIG welder, weld it on, and then we can try it out. Okay, so here's what I come up with. I was able to get the washer off and weld the little part I made on there. And I was able to tighten it down with a little bit of anti-seize behind there, so the washer and bolt kind of move independently. Otherwise, it's very hard to get it positioned and hold it, but I was able to get it. And then you want to position it to where your balancer is on 0, and you're on your #1 cylinder's compression stroke. And that's where you're going to trigger this Hall sensor, okay? So another thing is that this Hall sensor requires a 1.5 millimeter gap, air gap, okay? So you just get, you know, whatever, get your feeler gauges out, and you're gonna screw this down, which is really nice that it's all threaded. So you just screw it down until you get your air gap, and then tighten this bolt, and you're good to go, okay? Again, this is like, kind of like just slapped together to prove the concept. But if this works, and anybody's interested in this, I'm gonna make a kit that is like solid, you know, like this is gonna be like 1/4" aluminum, and we'll do it on the CNC over there. And then I know they sell these washers and bolts. I'll just buy a bunch of these and, you know, weld them up, and you can have this kit for really cheap. Like this would be much less than the other kits on the market that would require you to buy their cam gear. Okay, that's all the kits that I've seen, you have to buy their cam gear. This, you can use stock cam gears. Or if you have aftermarket cam gears, you just change out the bolt. You know, like for instance over here, let's say you had BC cam gears. Well, you would just change out the bolt, and then it would have that, you know, that little tab sticking out, and that's where you would connect it. It would work on this too. I mean, it would, because I have the same, you know, I have the 2 same bolts there. I don't use any of that on this, but yeah, I mean, this should definitely work. And then you can route this wherever you want. You know, we could route it this way, and that's all you would see is just that. I know there's another nice kit on the market that triggers back here, and it kind of goes over the cam cap, it's a really nice kit, but that's like $600 or $700 for that kit. I mean, I probably have, like, I got the sensor for free, but these are only like 30 bucks. And then these little standoffs were a couple bucks, and then this piece of aluminum is gonna be a couple bucks. I mean, this whole thing here is probably $10. I mean, I'm not even kidding. It's like $10 worth of stuff here, not including the sensor. So 10 plus 30 for the sensor, you're looking at 40 bucks, okay? So, and if it works, you're good to go. You got it. You have a cam sensor, okay? So anyway, let me wire this up. We'll try it out, and then I'll finish up this video, and yeah. All right, guys, so I got this set up here with my little multimeter and a 9-volt battery running the sensor. So typically you would hook the sensor on your ECU up to one of your 5-volt outputs, and that will run the sensor. It can run from like 5 to 24. So right now, like I said, I just have it running off 9 volts. You can see it's 8.39 on the multimeter running through the sensor. And then as we sweep it with our little metal pointer here, it's gonna go down to 0, okay? So a Hall sensor is a square wave, so it's like a pulse, okay? Whereas like a VR sensor, those are more of like a sine wave. They're different than Hall sensors. So I'm just gonna show you how it works. I'll go ahead and just turn the motor over by hand, and then we'll also do it with the starter. But I just want to show you guys it go from, when I see how close I am to it, I'm going to sweep it now. And you're going to see this go to 0. There it goes to 0. Okay, and then we go past it. I'm going to go past it. And it goes back to 8. Okay. So I'm going to show you guys. So on this multimeter, you can't run the starter and be able to see the pulse, because this multimeter is not fast enough to react. Okay, so but what we can do is we can put it on AC. Okay, and what it's going to do, it's going to show you a pulse as it's sweeping past the Hall sensor. So let me go ahead and hit the starter. So you can see it pulsing, and that means it's working perfect. Okay, so on an oscilloscope, you would see that as a pulse, like a square wave, okay? So the ECU is gonna be able to definitely read that, and it's gonna be able to run this thing as full sequential. So my theory worked, and we should have no problems with it. Anyway, that's probably gonna do it for this video. Hope you guys learned something. The next one, hopefully we'll be able to get this thing fired up. I'm gonna start wiring the coils and the injectors, and get the ECU all wired up. I have a little relay box here I got from Amazon. That was really cheap, like $35. And it's got a bunch of relays in it and a bunch of fuses. I'm only gonna be using it for this stand. I'm not gonna be like selling that or anything like that with the harness. That will just stay with the stands for testing purposes only. So yeah, got the fuel system all done. Flex fuel sensor here. We're gonna wire that in. We're gonna have I have a MAC valve here for the boost control. So this will be wired up as well. This is all for, like I told you in the last video, this is for someone who wants me to build him a harness. So these are all the different features he wants. He wants, you know, the boost control, the flex fuel. He wants to be able to turn on his fuel pump, all that. So, and he's also going to run a hall sensor too, but he may run it here or he may get a kit like this. So I'm going to put it on a Deutsch connector here, and then he can put it wherever he wants, there or there. So that's pretty much how, if I start doing harnesses, that's pretty much how I'm going to do it. Is some of the stuff that can be moved around, I'll put it on a connector. That way you can run it the correct length to wherever it's at. Also, like the oxygen sensor, you know, you don't know where that's going to be. It could be up here, it could be down below, but you know, you kind of want to, I mean, that I probably wouldn't put a connector on because there's like 6 wires on that. So that you could always pull that into the car and kind of tuck it if you wanted to, but I mean, it's so close to right here. So this is typically where you're going to have your O2 sensor. But anyway, I'm kind of rambling now. So that's going to do it for this video, guys. Hopefully the next one, we're firing this thing up. So check y'all later.